All right, so even digits only is the next one. All right, let's check it out. We want to check if all the digits of a given integer are even. Okay, so again, I mean, it doesn't seem like it's a super complicated thing we're being asked here. Maybe there's like a variety of ways we could look at it. And as it turns out, yeah, there's a variety of ways we could look at this. So again, just like the previous one, I don't think this problem is really complicated enough to merit us going through like a whole game plan, structuring it with comments, going to the whiteboard and doing diagrams and stuff. I think it's relatively clear what we're trying to do here. We're just trying to check, is every single digit in the number even? And if not, then we're going to return false. So like this one over here had a 3 in it. That's not even, so that's enough for us to say false. Okay, great. So we're gonna look at two different strategies. Well, okay, we're probably gonna do about 4 like we did for the previous one, but we're mainly gonna be looking at two types of strategies. So the first type is where we're gonna convert n to a string, and then the second type is, maybe we'll see after that, is there a way we can do that without converting to a string? So that's basically our game plan here. All right, let's get started. So basically, converting to a string. I guess, we could say something like let s be assigned the value of n dot toString. Right? Probably going to use that. And what do we want to do here? Well, basically what we want to do is a filter, right? We want to do s dot filter, and we want to check for each character. Should I call it character or should I call it digit? I'll call it, Okay, here's the issue actually. Let's go with this for now. We'll say dot filter character mod 2 equals 1. So we'll look for the odd digits. And actually for now, let's just return this. We'll see what we get. And what we expect is basically something just containing the odd digits of the number. And so we'll say, if there are some of those, if dot length is greater than 0, then false. We don't have all even digits here. Now here's the problem. S.filter is not a function. I made this a string. I didn't make it an array. So to make it an array, there are a couple ways we could do that. So we could do s.split like this, dot filter. And then if we do it that way, well, let's run that and see what that gives us. So, empty, 3. Okay, great. I'm a little surprised by this because I was kind of expecting this part to not work since, after all, this is a string, right? It's got the quotation marks around it. That's not a number, that's a string. So the fact that we're able to do modulus on it and compare it to 1, that means there's some typecasting happening here when it's actually doing that operation. So, okay, that's good to keep in mind. If we wanted to be totally proper about this, we'd probably want to do like a parse int on character before we mod it by 2. Or maybe we could even, before the dot filter, we could even do something like this and say like a dot map first, which just takes x to parse int x, and then put the filter after that, so that basically after we split it into the array, we're putting it back into an array of numbers. And now we should see how it's not a string anymore? We don't have the quotation marks around it. So that's basically because we already did the conversion ahead of time. Okay, so before we move on, I just wanted to say one other thing. Instead of the dot split, and in some ways I think this is a bit better because it's a little more clear, we could do array.from s, and that means it's going to create an array from the characters of the string s. And notice it's working exactly the same way as before. And what we're really trying to check is this whole thing, okay, we took the number, we converted it to a string, converted the string to an array, mapped the array to an array of numbers, not just like strings that look like numbers, but numbers. And then we did a filter on that. And now we're going to say if there was stuff in there, if the length of that thing was greater than 0, well then, actually, sorry, that's not what we want to check. We want to check if it was equal to 0, because if there were none of those, if there weren't any characters that were odd, well, that means we're good. Like that's that's what it means to have all even characters, right? Okay, so great. We're passing all the tests here, but I don't really like how messy this is looking, so maybe we'll say something like let digits be assigned the value of array.from s.map, and we'll do all of this. Okay, so that's going to be digits. And then let's say let odd digits be assigned the value of digits.filter, and I guess we don't want to call it character anymore. We want to call it digit. So digit mod 2 is 1. Those are going to be our odd digits. And instead of an X here, let's make that character, just to sort of make it more clear to the reader why we're actually doing the map on this thing. So to take it from a character into a proper digit. And then from here, all we need to do is say odd digits dot length equals 0. That's the thing we're checking for here. So let's run that. And there we go. Okay, so it's passing all the visible tests. Is it going to pass the hidden tests as well? Let's give it a run. We'll see what happens. Great. Okay, nice stuff. That feels good. And we're 40% of the way done, Reigns of Reason. But maybe before we move on, we'll do a couple other things here. Okay, so that was our first attempt. That was where we converted it to a string. We got the digits, we found odd digits, and then we returned whether or not the length of that was going to be 0. And yeah, I agree with you, ATD. This one does seem kind of simple compared to the other ones. I mean, basically, like, the thing about the arcade is it's not like... okay, so if this is like what task it is, like the task number, so what are we on now, like 27, 26? And then this is difficulty over here, difficulty. Okay, I had to think a minute for that sideways Y, but yeah, okay, so what we're not looking at is, you know, something like this. And what we're also not looking at is something like this, thankfully, I guess. What we're looking at is more like, you know, it starts off with add, like add 2 numbers, very, very simple. And then it kind of gets a little more complicated. And then we have task 7, and then it, you know, it kind of mellows out. It gets a little trickier. And then it kind of gets a little easier for a little while. And then we'll get to task 33. And then from there, it's going to do something more like this. That's what I found. I found that, like, as we got closer to the end of it, it definitely got kind of progressively more challenging. And it'll sort of lead into the core to some extent. Like, I'd say the core is a little more like, you know, I guess at the beginning, it actually seems a little less challenging than the intro, but then eventually it gets more complicated, and it just, well, actually, sorry, I kind of messed up that last part there. At the end, it pretty much ramps up, like what is it called? The Cliffs of Pain? Like the last bit, whoops, that was the color I wanted. The last bit is just like, oh boy, it's on another level. So yeah, that's true, exactly. Like if they just threw hard stuff at you, it might not keep you motivated, right? So yeah, I agree. I think it's good to have tasks that aren't too difficult peppered in, you know, kind of an ego boost kind of thing, keep you motivated. So, okay. Now that we're done with this very, very scientific graph over here, let's go back to what we were looking at. So, okay. What have we done so far? We've done one method. We basically converted this thing to a string, got the digits out of that, found the odd digits, and then just said, well, if there are any odd digits, it's going to be false. If there are no odd digits, it's true. So that's why we return a Boolean at the end. We're going to do some of the same stuff for this next attempt. I'm just going to copy paste that, and then what are we going to do differently here? Well, we're not going to do this odd digits thing, because I think as soon as we have digits, we have enough to be able to get sort of our final statement. All we need to basically check is that for every one of the digits, they're even, right? So digit gets mapped to digit mod 2 equals 0. Okay, so we're not saying that that it's equal to 1 like we were down below, because that was for odd digits. Now we're just trying to say, are they all even digits? So remember, we looked at every last time. It's a bit like filter, except it's going to return true only if we get a true for every single one of the array elements. And there's a corresponding one called sum, S-O-M-E, and we could use that here as well. You know, like we could say something like return not digits dot sum, and then digit gets mapped to digit mod 2 equals 1. So basically these are very similar. In fact, I think they're pretty much the same, but we'll know that for sure once we get the results of our tests here. So I guess for now, let's just comment that out, because this is the thing that we're actually running the tests on right now. And after that completes, we'll switch it up and we'll see if we get the same value out of this thing down here. Because really we should. I mean, if you think about it, this is basically saying, is every one of the digits odd? Is every one of the digits even? Whereas this one down here is saying, is not one of them odd? Okay, that's kind of a strange way to word it. But yeah, okay, this passed at the top here, so that's good. Let's see if this is another equivalent way of saying the same thing. And if it is, I would wonder which is more efficient. So you probably notice this one executed a lot faster, but I don't think that's an actual reflection of the actual computation time of these things. Okay, so which one of these things is better? Well, they're very close, they're very similar, but I'm going to go with this one up top just because I feel semantically every maybe makes a little more sense to the reader. It's that what we're trying to check. Are they all even? So maybe I'll even put a comment about that. Are all the digits even? Or maybe is every digit even? Just to sort of use the word every like we have down here. Anyway, okay, that's another way that we can do it. That's yeah, perfectly fine, perfectly acceptable. But now at this point we're working with strings, right? So let's grab this again and we'll put it up here. Something you may remember is that when we're working with strings, we can do some really efficient stuff with regular expressions. So maybe we'll make a regular expression for this. We'll just say, we'll do a regular expression in here and we'll do a dot test on s, and that's gonna be it. So what are we checking for? Well, we wanna check if s is all digits, first of all, right? So we could say /d and then put a plus, one or more of these things. All right, and that's just gonna say, is it one or more digit? And yeah, this thing is. I mean, I think it's going to return true for all of these unless we gave it like a string or something. And actually, just to be more certain of that, let's say from the beginning to the end, it's all digits, just a whole bunch of digits. Okay, great. The thing is, we're not looking at just any digits here. So instead of /d, let's do this. So remember, anything in the square brackets are like our options. It'll accept any of these things. So if it matches a single one, that's good. So what do we want to accept? We want to accept 0, 2, 4, 6, and 8. Yeah, those are even digits. Let's run this. So, wow, that's a lot simpler. In fact, you know, if we wanted to put it all together like this, we could just put that right in here and then just say we're just returning that thing. So, okay, not bad. That's pretty not bad when we compare it to some of these other guys. I think this is probably going to be efficient, but like we talked about, I don't actually know how the time complexity of regular expressions compares. But yeah, that's pretty nice. Okay, and one thing I just want to mention before we move on, 0 is an even digit. Some people are not convinced by that. So basically the reason why 0 is considered an even digit is if you divide it by 2, you don't get a remainder. So simple as that, you get 0 with no remainder. That's all it really means. If you divide something by 2 and you don't get a remainder, it's even. Okay, so that's probably, well, at least in some ways, that's the best way we can do this with strings. So now the question is, how could we do this with not strings? Good question. So basically, I think we've used this strategy before, but the way it's going to work is we're going to do a loop and we're going to say while n is greater than 0. And then at the end of each iteration of this loop, we're going to say n is assigned the value of math.floor of n divided by 10. Okay, so why are we doing that? Well, let's use this one as an example. And let's get a really sick color in here. Okay, great. So 6, 4, 2, 3, 8, 6. Okay, so basically we've got this number here, and we're saying while this is greater than 0, we're going to do this. So, okay, is this greater than 0? Yeah, it is. Okay, so this is n right now, but then after we do the math.floor of n divided by 10, well, what would n divided by 10 be? It would be 64,283.6. We're basically just moving the decimal point one place. So the next one would be, if we're taking the dot floor of that, it would be just 64,238 and not the 0.6 because it's going to round it down because it's a floor. All right, next iteration of the loop, we would be looking at 6,423, and then 642, and then after that just 64, and then just 6. Okay, so why do we want to do it this way? Well, the reason, and let's get another sick color. So let's go for like kind of a gold color would be cool. Yeah. Okay, so the reason we want to do this is because if we look at the last digit in each case here, we've got a 6. We've got a 6, we've got an 8, we've got a 3, we've got a 2, we've got a 4, we've got a 6. It's the number. You know, this is a way of getting all the digits of the number. Now, if I just want the last one, then I'm going to be doing an n mod 10. So again, that's a percent symbol. I haven't had very good luck drawing those, but here, let's clean it up a little bit. There we go. All right, so n mod 10 is just going to be the final digit here. So let's do that. We'll say let digit be assigned the value of n mod 10. And then if digit mod 2 is equal to 1, in other words, if it's odd, then we're going to return false. And if we can make it through this whole loop without that happening, then we'll return true at the end. So let's run that. Let's compress this a little bit, and there we go. Okay, so that's pretty nice. We can submit that, see if it passes all the hiddens. And it does. Okay, so what I like a lot better about this one is the fact that we're just using numbers. We're not converting it to a string to make this work. We're just keeping it a number, and I feel like that's a little more natural for this problem. But I feel like it could be just a little bit better. So I'm gonna copy this back up here, and there's something I wanted to point out. So specifically, it was, let's get that example back in here. Let's choose some other sick colors. Okay, so maybe like a lavender. Yeah, that's nice. And maybe we'll use the other one, for example. So we'll say 2, 4, 8, 6, 2, 2. Okay, so the issue I have with this is basically, okay, hold on. What goes good with lavender? What would be a good color combo? Maybe like a green or something like that. Maybe like yeah, like kind of a pale green, like a sea foam. Okay, great. So, okay, basically we're taking this digit, right? And that's our n mod 10. And then we're saying, is this digit odd or even? So in other words, after that, after we've already taken n mod 10, we're gonna do mod 2 on that. But here's the thing, if a number ends with an even digit, then it's an even number. If a number ends with an odd digit, then it's an odd number. Okay, so we don't need to do both of these. We don't need to isolate the last digit to check if the last digit is even or odd. I mean, if the last digit is odd, the whole number is odd. If the last digit is even, the whole number is even. So we don't need to do this. We don't need to do this digit business. All we need to do is see if n mod 2 is equal to 1. In that case, we'll return false. So if we run this, it should work exactly the same as before. Great. Could it be even better? It could. And the reason I say that is because notice we used a while loop here. But if you think about it, the reason I would use a while loop instead of a for loop is because if I used a for loop, it would basically look like this. You know, we'd have empty space before and after. We don't have an initial condition we're trying to set up. We don't have something that we're repeating at the end of the loop every time. Although we actually kind of do. You know, if we look at this thing, n is assigned the value of math.floor and divided by 10. That is basically just saying, get it ready for the next iteration. So we don't need that. We can just do it without that. And it should work exactly the same way, because this is something that's going to get executed at the end of each iteration of the loop. And then it's going to compare it to this over here. Okay, great. So that's getting more efficient. And since this is now just one line, it could look like this. Could make this like really, really efficient looking. And even like, okay, first of all, let's run the test. Let's see if that's still running, just to be sure. It is, great. The other thing is this n is greater than 0. Keep in mind, if n reaches a point where it's 0, then that gets typecast to false. So really we could just say n, and we can try running this. And is it gonna work the same way? You bet it does. But I am gonna leave that n is greater than 0 in there just because, I mean, look, I'm saving 2 characters and I'm losing a lot of like, a lot of the self-explanatory quality of this. Like I like that this is actually saying n is greater than 0. Like it makes sense to the reader a little more than just putting an n in there. And we kind of want to be gentle to the reader at this point, especially because we're throwing this at them. You know, we're giving this like little winky face emoticon right here, right after the for. So, you know, they're already in a position where they might be confused about that. Let's be gentle with the next part. Okay, so I think that's working good. Let's see if it passes all the hidden tests. And it does. Okay, great. So, nice stuff. You know, take your pick, whichever one of these 5 you like the best. If you're wondering which one I like the best, I would say one of these 2. One of the number ones. I like the fact that we're not converting to a string. I think that's better hygiene. I don't know. Like it's just it's keeping it a little more natural. It's keeping it within the realm of numbers, and this is a question about numbers after all. So yeah, I think that's probably better. Anyway, yeah, I'd say that's it for that one. Nice job, everyone. We'll move on. So we'll go back to the range.